Okay, so here are some extra problems from section 11.5 that we went through in class. So for each pair of similar figures, find the area of the figure in green. Now, this is in black and white because it's off my printer at home, so it's not going to be it's not in green, but it's pretty obvious that, excuse me, we're looking for this area here. So we'll call that guy area 1. Here's area 2. Now the theorem tells us that the ratio of the sides, or the scale factor of the sides, which is 10 to 18, or 5 to 9, that's the scale factor. But to get the area scale factor, you square both of those. So 25 to 81, that's the area scale factor. Now once we have that, this becomes really easy because we'll call this guy x. 10 to, or the 10 is really corresponding to the 5, which is the 25. 81's the other one. This guy actually becomes literally no work because it's 25 over x. So normally I have to cross multiply and solve, but obviously x is 81 millimeters squared because 25 over 81 equals 25 over 81. Okay, number 10 was the next one we did out of the book, or another one we did out of the book. This time we're actually working backwards. We got to do two things though. Find the scale factor of blue to green, and we're going to call this guy blue. We're going to call this guy green, even though that might be what it is. I don't know off the top of my head. Then we're going to find x. Okay, so first thing we'll do is we'll compare the areas. That's the area scale factors. Divided by 2, it's 36 over 25. That's area scale factor, ASF. To get the actual scale factor, you take the square root of that. Well, the square root of 36 is 6, square root of 25 is 5. There's our actual scale factor, 6 to 5. So now 6 over 5 equals 12, because that corresponds to the 36 or the 72, over x, because that guy corresponds to the 50. And now we solve this, we get 6x is 60, divide by 6, x equals 10 meters. Okay, now, last problem we're going to look at, number 16. Number 16. So a polygon has an area of 144 square meters. Okay, if the area is doubled, how does each side length change? Um, here's what we're gonna do. Uh, let's pretend this is a square. Let's make it easy that way. Um, yeah. So no, actually, we don't even need to do that. Let's talk about A. So if the area is doubled, this is A1. The area is doubled, which is area 2, is 288. All right. So area 2 to area 1, that's the scale factor area. That would be 288 to 144, which is 2 to 1. Now again, I doubled the area. So to find the side length comparison, I would take the square root of this. So become root 2 to 1. So what that means is, if the side length originally were 12, I would have to multiply it by a root 2 to get the new side length. So what happens each side length? It's multiplied by, that's sloppy, root 2. Okay. So B, how does each side length change if the area is tripled? Well, that would mean that this then is, what is 144 times 3? I know I could do it in my head, but I don't feel like it because I've just done the entire chapter of videos here. 144 times 3, 432. So area 2 would be 432. So 432 over 144 becomes 3 to 1. Now again, I take the square root of that then. It'd be root 3 to root 1, which is root 3 to 1. So now what I would do is multiply, I forgot my L, by root 3. So if this side were 12, it'd be 12 root 3 then. Okay. So C is what's the change in side length if the area is increased by a factor of x. Well, if hopefully you notice that Hay1 is doubled, it's root 2, tripled, root 3. So C would be multiplied by square root of x. There we go. Okay.